Okay, so just a brief explanation on momentum first. So start off first, basics. Object A, this object here, is moving towards object B. Object A is made up of atoms with electrons on the outside. So we're looking at the edge of object A in this picture. Object B is stationary, it is not moving. Object B is also made of atoms with electrons around the outside. In object A and object B, the electrons interact. So here is my object A, here is my object B. This would be the barrier that we see in real life, but we can see there is an interaction between the electrons and the edges of these objects. Electrons have negative charge. So this is negative, this is negative, 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 negative. When two negative charges interact, they repel each other. So at this point, the two negative charges and my two electrons are interacting and repelling each other. There's a force that's being exerted. This force requires energy. When that happens, my electrons will move apart from each other. This can help us explain why collisions can happen. Because the electrons are repelling each other, the objects will repel too. Newton's third law says that the interaction will be equal but opposite in direction. This can cause objects in the collision to move in opposite directions, but this repulsion can also cause objects to move in the same direction. So if I had another object, object C, and it bumped into object D that had very little velocity in that direction, then they could end up going the same direction afterwards. But it's all because of the force of repulsion when the two objects meet. Now, energy can either be created or destroyed. Energy is the ability to do work, and there is work that is being done here, which means the total amount of work that can be done before the collision will be equal to the total amount of work that can be done after the collision. The momentum before the collision or the explosion is equal to the total momentum after the event. And here are some examples. This is a gun with a bullet in it. Before firing, the total momentum is 0 because there is no motion. So if the gun has got a mass of 3 kilograms, and the gun has got a velocity of 0 meters per second, then the momentum can be given as mass times velocity. The momentum will be 3 times 0, which will equal 0 kilogram meters per second. The bullet has got a mass of 0.04 kilograms. It also has a velocity of 0 meters per second. Momentum can be given as momentum equals mass times velocity. 0.04 times 0 will give me 0 kilogram meters per second. The total momentum here is 0 kilogram meters per second. Now, one of the questions we get given is, well, if there's no momentum before, this doesn't make sense, because afterwards, this bullet is moving and the gun is moving. So this has momentum and this also has momentum. So why can that equal 0? Well, it's all down to the velocities. If I have a velocity going in one direction, I can call that a negative velocity. If I have a velocity going in another direction, in the opposite direction, I can have a positive velocity. And it doesn't matter which one is which. This could be positive and this could be negative. It just describes the relative direction. This is because velocity is a vector. Vectors have to have direction. Now we can see that the momentum will actually cancel each other out. The mass of this gun is 3 kilograms. It has a velocity of minus 20 meters per second, giving it a momentum of minus 60 kilograms meters per second. Mass of the bullet is 0.04 kilograms with a velocity of positive 1,500 meters per second, giving it a momentum of 60 kilogram meters per second. Minus 60 plus 60 equals 0. So the total momentum before and the total momentum afterwards was 0 kilogram meters per second and 0 kilogram meters per second. Another example would be a bomb. This bomb has got a mass of 10 kilograms. It has got a velocity of 0 meters per second. Momentum is given as mass times velocity. 10 times 0 is equal to 0 kilogram meters per second. The total momentum here is going to equal 0 kilogram meters per second. The mass of this part of the bomb is 4 kilograms. The velocity of this part of the bomb is minus 30 kilograms, meaning the momentum will be negative 120 kilogram meters per second. The mass of this part of the bomb is 6 kilograms. The velocity of this part of the bomb is 20 meters per second, giving it a momentum of plus 120 kilogram meters per second. Minus 120 plus 120 equals 0. So the second momentum, the after momentum, is also 0 kilogram meters per second. The principle in play here is the conservation of momentum. Conservation just means it's the same before as it is afterwards. Conservation of momentum means that momentum before will be the same as the momentum after the event. Another example, here's a cannonball. I have a cannon of mass 400 kilograms. I have a ball of mass 8 kilograms. The velocity is 0. So the momentum of the cannon is 0. The momentum of the ball is 0. So overall, 0 kilogram meters per second. The mass of the cannon is 400 kilograms. The velocity is minus 4 meters per second. The momentum is given as 400 times minus 0.4, giving me a momentum of negative 160 kilogram meters per second. The mass of the ball is 8 kilograms. The velocity is 20 meters per second, giving me a momentum of positive 160 kilogram meters per second. The momentum before is the momentum after. It doesn't always work like that. Sometimes we can have situations where we have one object that's moving and another object that isn't moving. So M1 is 3 kilograms, V1 is 5 meters per second. My momentum, I don't know, but that can be found by multiplying the mass times the velocity. Momentum here, M2, 4 kilograms. Pardon me, the mass for B is 4 kilograms. The velocity, 0 meters per second. Momentum can be worked out. I mean, we know what it is just by looking at it, because 4 times 0 is 0. But we're still going to show our working out so that we don't make any silly mistakes. The total momentum, therefore, will be the momentum of A, 15, plus the momentum of B, 0. My total momentum is 15 kilogram meters per second. How can we use this information to figure out the velocity of this object? Well, we have the new mass, because the mass of this object, when they're stuck together, will be equal to the mass of A, which is 3, and the mass of B, which is 4, giving me my M3 as 7 kilograms. I don't know the velocity, but I do know the total amount of momentum. The momentum before has to be the same as the momentum afterwards. So I can say that my momentum is 15 kilogram meters per second. Show my working out. Rearrange my equation for V. Momentum is 15 divided by 7, giving me a velocity of 2.14. Another example. of when this can be used like this. M1, 16 kilograms. Sorry, someone just came in and asked a question. I got distracted for a second. Yeah, that's fine. Okay, so momentum is equal to mass times velocity. Momentum is equal to 16 times 4. Momentum is equal to, doing this in the calculator just in case I make a mistake, equal to 80 kilogram meters per second. Now it's important we look here, because I now have an object that is going in this direction and an object that is going in this direction. We've assigned this one as having positive velocity and this one as having negative velocity. So V2 is minus 6 meters per second. Give me my second momentum. 18 times minus 6. My momentum is equal to minus 108 kilogram meters per second. So how do I find my total momentum? I add these two together. 80 minus 108 is equal to minus 28 kilogram meters per second. That is my total momentum before the collision. How do I find the velocity that these cars are now going at? And also what direction they are going. So we've assigned this direction as negative and this direction as positive. The mass of A was 16. The mass of B was 18. Total mass will be 16 plus 18. Because the total mass of A and the total mass of B is now stuck together. So my total mass will be 34 kilograms. I can now find the velocity because the momentum before will have to equal the momentum afterwards. Mass, 34 kilograms. Momentum, minus 28 kilograms. Velocity, I don't know how many meters per second. Momentum is equal to mass times velocity. Velocity is equal to momentum divided by mass. Velocity will equal minus 28 divided by 34. Velocity will be minus 0.82 meters per second. So this object is going to be going in the negative direction at 0.82 meters per second. Now, let's have a look at some further examples. I'm going to go through them one by one. They're the same as the ones that are in your in the sheet that you have. I'm not going to give you all the written answers just because I don't have space to type them. Principle of conservation of momentum. The momentum before the event is equal to the momentum after the event. What is a closed system? It's a system of one or more objects in which there is no increase or decrease of energy. In an explosion, the two pieces always move in opposite directions because momentum has to be conserved. So we have to have a positive velocity and a negative velocity. Copy the diagram of the bullet and gun and explain how momentum is conserved. Well, it'll be the same thing as this fill in the blanks bit here. Before the explosion, the system has 0 momentum as the velocity is 0. Momentum is conserved. So total momentum in the system after the explosion is also 0 kilogram meters per second. Momentum 1 plus momentum 2 equals 0, because that's momentum of the bomb or the other part of the bomb or the gun and the bullet or whatever. After the explosion, the 6 kilogram piece moves to the right with the velocity of, what are we looking at here? 6 kilograms, 20 meters per second. This momentum is 6 times 20, which is 120 kilogram meters per second. Because the momentum is conserved, the momentum of the 4 kilogram piece must also be minus 120 kilogram meters per second. Therefore, the velocity of the 4 kilogram piece is 120 divided by 4, which is minus 30 meters per second. The diagram shows a system comprising a cannon and cannonball before and after firing. When the cannon is fired, the cannon recoils and moves to the left with a velocity of minus 0.4 meters per second. Explain why using the following words. Momentum is conserved, so the momentum before must equal the momentum afterwards. There was zero velocity for my cannonball at the beginning, before the event started, so therefore must be there must be zero momentum in the before the event. After, there must also be zero momentum, because momentum before the event is equal to momentum after the event. The velocities therefore had to go in opposite directions because the mass is constant in this example. And this is where the math stuff. So all the rest of that, you'll get the answers on the piece of paper, on the PowerPoint. Parent and child push off against each other from a resting position. Find the velocity of the child. Well, we've got the mass of the mother is 90 kilograms and the velocity is 0 meters per second. Momentum is equal to mass times velocity. So we'll do the mass of the mother is equal to 90 kilograms. Mass of the velocity of the mother is equal to 0 meters per second. And the momentum is going to equal 0 kilogram meters per second, because 90 times 0 is 0. Momentum is mass times velocity. Mass of the child is 40 kilograms. The velocity of the child is 0 meters per second. Momentum is equal to 0 kilogram meters per second. So the total momentum before will equal 0 kilogram meters per second. The total momentum afterwards must therefore also be 0 kilogram meters per second. We've got the velocity of the mother as minus 0.6 meters per second. We're trying to find the velocity of the child. It looks like we only have one piece of data there, so how are we going to find our answer? Well, the mass hasn't changed. The mass will still equal 90 kilograms for the mother, and the mass will still equal 40 kilograms for the child, which means we can find the momentum by multiplying the mass by the velocity. So mass 90 kilograms, velocity mother minus 0.6 meters per second. Momentum will equal, I don't know how many kilogram meters per second. Actually, I tell you what I'm going to do. I'm kind of running out of space, so I'm not going to show the full working out for this, for I am special. 90 times minus 0.6, giving me minus 54 kilogram meters per second. Okay, this is the total momentum of the parent, of the mother. I've just said mother, but it could be anybody. I have the mass of the child, but I don't have the momentum of the child. What's the momentum? Well, if the total momentum is 0 kilogram meters per second, and the momentum of the mother is negative 54 kilogram meters per second, then the momentum of the child must be positive 54 kilogram meters per second, so that they can equal 0. The mass of the child has not changed. It is still 40 kilograms. And the velocity we can find out by rearranging our equation. Momentum is mass times velocity. Momentum divided by mass will equal velocity. Momentum, 54, divided by 40, gives me 1.35 meters per second. Now notice I'm giving this as positive velocity because we've given this as negative velocity and negative momentum. Car A collides with car B and sticks to it as shown. Now what I'm going to do here is I'm not going to show the full working out because I don't have the space, but to find the momentum we multiply the mass by the velocity. So momentum of this is equal to 2 kilogram meters per second. The momentum of this is equal to 0 kilogram meters per second, because momentum is mass times velocity. 11 times 0 is 0. Total momentum, 2 kilogram meters per second. The mass of A is 10, the mass of B is 11, so M3 will equal 21 kilograms. M3 with 21 kilograms will have a momentum of 2 kilogram meters per second. So to find the velocity, I just need to rearrange my equation. Momentum equals mass times velocity. Velocity equals momentum divided by mass. 2 divided by 21 0.01 or 0.095. Another example, car A collides with car B. 100 times 8 gives me a momentum of 800 kilogram meters per second. 50 times 0 gives me momentum of 0 kilogram meters per second. Total, the momentum before P1, I'm going to call that, or PB, doesn't really, whatever you like, 800 kilogram meters per second. M3 is going to be the mass of A, which is 100, plus the mass of B, which is 50, giving me a mass of 150 kilograms. The velocity, 3, I do not know. That's right, it's a very bad 3. I'm writing with my mouse, so it gets a bit difficult. And the momentum is going to be 800 kilogram meters per second. Momentum is equal to mass times volume. Mass times volume, velocity, pardon me. Velocity is momentum divided by mass. How many times have I said that? Which will be the same as 800 divided by 150. Again, just do that in the calculator to be sure. Give me my velocity of 5.33 meters per second. Another example. Momentum will be the mass times the velocity. This will be, wait, of course, it'll be 3,000, sorry, 1, 2, 3 kilogram meters per second. P2 will be 80 times 0, which is 0 kilogram meters per second, giving me my total velocity, my total momentum is 3,000 kilogram meters per second. The mass of A is 60, the mass of B is 80. Give me a total mass, M3, 140 kilograms. B3, I do not know in meters per second, but I do know that the momentum is going to have to be 3,000 kilogram meters per second, because momentum before has to be the same. Has to be the same as momentum afterwards. Momentum is mass times velocity. Velocity is momentum divided by mass. Velocity is 3,000 divided by 140. 21.42. 21.4, pardon me, 3 meters per second. And we just keep on doing this. The only difference between what we've done in the past and what we're doing now is we have got this object moving in another direction, in the opposite direction. M2 is 55, V2 is minus 20 meters per second, giving me a momentum of minus negative 1,100 kilogram meters per second. So my total momentum then is 300, take away 1,100, negative 800 kilogram meters per second. That's the total momentum beforehand. Afterwards, they're stuck together, but we have a mass here of 10 and a mass here of 55. Sorry, just double checking. Yeah. So the total momentum was negative 800 kilogram meters per second before. It is going to be negative 800 kilogram meters per second afterwards. Total mass will be 65 kilograms. The velocity will be, I do not know how many meters per second. The momentum will be negative 800 kilogram meters per second. Momentum equals mass times velocity. Velocity is equal to momentum divided by mass. Velocity will equal negative 800. And it's important we do negative 800 divided by 65. Give me a velocity of minus 12.3 kilogram, not kilogram, pardon me, just meters per second. Now, why is the negative important? Well, we said that this was going to be the positive direction and this was going to be the negative direction. So it tells me that my cart is now moving in this direction at negative 12.3 meters per second. So find the velocity of the cars, take the direction they will move in, do the same thing. 8 times 4, 32. 15 times minus 6, minus 90. Giving me a total momentum before of minus 58 kilogram meters per second. Mass of A is 8, the mass of B is 15. 8 plus 15 will equal 23. The momentum will equal negative 58 kilogram meters per second, and the velocity we will work out in just a moment. Momentum is equal to mass times velocity. Velocity is momentum divided by mass. Velocity is negative 58 divided by 23, giving me 2.52. Negative, going in this direction because we've assigned that as the negative number. 144 plus 108 negative will equal 36 kilogram meters per second. Mass of A is 36, the mass of B is 18, giving me a total mass 54 kilograms. Total momentum 36 kilogram meters per second. And my velocity will be momentum divided by mass. At 0.66 meters per second. The principle that causes cars to behave in this way is the conservation of momentum. Okay, pause this here. We'll do much the same thing again in the intervention question. So mass is 14 kilograms, the velocity is 33 meters per second. Multiply those together. 462 is the momentum of this cab. This is 0, so 51 times 0 is equal to 0 kilogram meters per second. So the total momentum before is 462 kilogram meters per second. Mass of the car 14, the mass of this car is 51, giving me a total mass of 65 kilograms. We do not know the velocity in meters per second, but because the momentum before has to equal the momentum afterwards, I can say that momentum 3 is going to be equal to 462 kilogram meters per second. My equation, momentum is equal to mass times velocity. Momentum divided by mass will equal velocity. So that will be 462 over 65. Giving me an answer of 7.1 meters per second. 9 times 60, 540 meters, kilogram meters per second. 12 times 0, 0 kilogram meters per second. And just a reminder that you've got to do all of this working out every single step. I'm only doing it quickly for the sake of our 30-minute long video. So the total amount of momentum will be 540 kilogram meters per second. The mass here will be 9, the mass here will be 12, giving us a mass of 21 kilograms. I don't know the velocity, but because the momentum has to be the same before and afterwards, I'm going to say that momentum 3 is equal to 540 kilogram meters per second. Momentum is equal to mass times velocity. Momentum divided by mass is equal to the velocity is equal to 540 divided by 21, giving me an answer of, oops, don't press delete, press change, 25.71 meters per second. Oh, flying about the place now. So we find the momentum, which is mass times velocity. The momentum of this car is 240 kilogram meters per second. The momentum here will be 0 kilogram meters per second, meaning the total momentum before is 240 kilogram meters per second. Total momentum afterwards will also be 240 kilogram meters per second. The mass is constant, a mass of 48 and a mass of 52, meaning that my new mass is 100 kilograms. My velocity, I do not know. But my momentum has to be the same because momentum before the event is equal to momentum after the event. 240 kilogram meters per second. Momentum is equal to mass times velocity. Velocity is momentum divided by mass, which will equal 240 divided by 100, giving me the velocity of 2.4 meters per second. Here again, we've got cart A going in the positive direction, cart B going in the negative direction. Momentum here, 61 times 5, 305, plus. And here, 39 times minus 4. Momentum will be negative 156 kilogram meters per second. 305 take away 156 gives me a momentum of minus 149 kilogram meters per second. Momentum before will equal the momentum after the event. The mass of this is 61 plus 39 kilograms. Give me my new mass, M3, as 100 kilograms. The momentum will be negative 149 kilogram meters per second. And I do not know the velocity. Momentum is equal to mass times velocity. Momentum divided by mass will equal velocity. Minus 149 divided by 100 is equal to minus 1.49 is equal to the velocity. Now, minus means it's going to be going in this direction, so if ever you've got to say which direction it's going in, you can just get away with saying left. Find the velocity of the cars shown in the collision. 12 times 10 is 120 kilogram meters per second. And this is negative velocity, so it's going to be 35 times 6, giving me negative 210 kilogram meters per second, giving me an overall momentum of minus 90 kilogram meters per second. Momentum before must be the same as the momentum afterwards. The mass of this is 12 and 35. M3 will be 37 kilograms. We don't know the velocity in meters per second. Momentum is equal to minus 90 kilogram meters per second because momentum before has to be the same as momentum afterwards. Momentum is equal to mass times velocity. Velocity is equal to momentum divided by mass. Velocity will be minus 90 divided by 37. Give me a velocity of 2.43 meters per second. And another one, 97 times 12. To find the momentum, we multiply the mass by the velocity. 97 times 12 gives me a momentum of 1164 kilogram meters per second. 32 times 7, negative 7, because it's negative velocity, will give me a momentum of minus 224 kilogram meters per second, giving me a total momentum of 940 kilogram meters per second. The mass will equal 97 for A, we get that from up here, plus 32. Give me a total mass M3 of 129 kilograms. Don't know the velocity, but the momentum has to be the same, because momentum before will equal the momentum afterwards. Momentum equals mass times velocity. Velocity will be momentum divided by mass. 940 divided by 129. 129, giving me a velocity of, that's wrong, sorry, I pressed minus, which didn't make sense. Double checked it with my brain, now it does. Velocity of 7.29 meters per second. In a closed system, what happens to momentum in a collision? It is conserved. The same amount of momentum at the start as the end. Here are all the answers for all the questions, so you can pause now and have a look. And here are the answers for all the maths. Thank you very much for watching. Goodbye.